Hi, in this video I want to show you my current project. It's an electronic load that I've been working on for the past few months. So it all started when I needed to have a better estimate of the capacity left in batteries like this one. This is a lithium CR123A battery, and I'm using these ones in a network of temperature and humidity sensors like this. And since they have a very low duty cycle, I couldn't find any accurate discharge curves in the datasheets of the batteries or on the internet. So this sensor sleeps for 5 minutes, wakes up for 5 seconds, takes some measurements like temperature, humidity, and the voltage, and then sends this data to a base station. So the base station has to estimate the capacity left in the battery based on this voltage. So this means that it needs to have an accurate discharge curve that matches the discharge pattern of the sensor. So very low duty cycle. So initially I searched for schematics of and existing loads, but most of them were either analog or not precise enough. So I thought, what the hell, I'm gonna build my own. It sounded like a fun project. I honestly thought I can get it done in one weekend. I was very wrong. Anyway, this is the third revision. In the first two revisions, I was generating the reference voltage with a PWM signal. So in this one, I fixed that. I added the proper reference voltage and the digital to analog converter and the proper linear MOSFET. I will go over the schematic in a future video. Now I just want to show you how it looks like and how it works. The front panel. Here we have some air vents. We have a touch screen. I'm not using the touch right now, but I plan to implement it. We have two sets of banana plugs, one of them for connecting the load, the other one for the sense terminals. We have a rotary encoder. This is used to navigate the menu system and select options and so on. We have a load on-off button. And on the back side, we have the exhaust. We have the power and programming connector. It's a micro USB. And the SD card. The SD card is there to store the data. As you can imagine, discharging a battery with a low duty cycle can take weeks. So this generates a huge amount of data. I'm using the SD card to store this. Okay, so let's turn it on. Okay, so this is the main screen. We have three big sections. We have a top bar that shows the current mode, the 4-wire sensing on and off, if the SD card is present or not, and the MOSFET temperature. In the middle part here, we have the main values. We have the voltage, the energy in watt hours, in amp hours, the timer. We have the current, the power, the resistance, and the tracked value. As you can see, the tracked value connects with the current, because right now we're in constant current mode. If I'm changing the mode, if I'm changing the mode, it will the outline will change and the color as well to show you the current tracked value, the current mode. And in the bottom side here, it's not very visible, but there is a graph that shows all the values color coded and so on. So the navigation is done with a rotary encoder. You can for example, here we can change the set value. Let's put it to 100 milliamps. Okay. We can change some graph properties, like we can clear it. We can select what we want to see in the graph. We can change the time range and so on. And here we can change some settings, like 4-wire terminals. We can change the mode. We can reset the session. The text here should say reset session, not energy. We can start and stop programs. Programs are pre-recorded, user-recorded sequence of steps, like turning the load on, sleeping for a while, turning it off, and changing the set current, and so on. So you can actually customize your discharge pattern. Okay, so I have a battery connected here, and let's see how it works. So I'm gonna turn it on, and we have 100 milliamps. Let's set it to 500. let's turn it on. So as you can see, the timer started. We are reading 2.7 something volts, 501 milliamps. The load is not calibrated right now. There is a hidden calibration menu. So right now the reading is relying only on the tolerances of the components, in particular the resistor dividers and so on, and the voltage reference. It's accurate enough, as you can see. We have the power, the resistance, and so on. And the graph is already showing the voltage dropping, and the power, of course, because we're not in constant power mode. So let's go ahead and change the 4-wire mode. As you can see, the voltage jumps a little bit. I think it's 50 millivolts. Yeah, more or less. From that we can deduce the resistance of the load leads. So let's reset the session. And I'm gonna let this battery discharge, and that's it.